Welcome to the final part of the talk, Weekly Supervised Learning tutorial. We conclude the tutorial now. I am Song Junho. Computer vision is finally working. This is a very exciting time to live in. It's applied to object detection and the performance is super. And optical character recognition, you write something or you print something and you digitalize it. And biometrics, you check into a place without having to go through passwords and stuff like that, but you just simply show your face and you're good to go. Computer vision is also used in medical machine learning and self-driving cars. But behind the success, the driving force behind it is the growth of computing resources like GPU machines and also huge data, in particular huge annotation costs. For example, to annotate this single image on ImageNet 1K, multi-label annotation takes about 26 seconds per image. Think about how much time you have to spend on images when you have more than thousands and millions of images. This is even worse for semantic labeling annotation. If you want to do it per pixel, then it takes about 1.5 hours per image in the case of cityscapes. This is very expensive. And therefore, people have sought ways to not require the full supervision that you as the task you are trying to solve, but only require weaker forms of supervision for training the models. So for pixel-wise labeling, instead of requiring all images being pixel-wise labeled, in the training set, you may only require image-level labels or point-wise labels or bounding box labels, which are much cheaper to collect. So this is the summary slide of different types of supervision according to the discrepancy between training time and test time annotations. So when the training time and test time task output types are equal, then you have full supervision case. When the training time annotations are weaker and therefore cheaper, then we call it weak supervision. And vice versa. We call it strong supervision when the signal is training signal is stronger than what you need. And this tutorial is about the upper left corner. So we briefly recap the tutorial. Part 1 was about going from image level labels to bounding boxes. It's called weakly supervised object detection. And part 2 was about going from image level labels or bounding boxes to pixel level outputs. Part 3 was a bit special. Instead of fixing the type of supervision in the first place, the model actively asks for the needed type of supervision to the human user. And this is called human in the loop annotation. And part 4 is a general topic for weak supervision, how to evaluate methods well. And the overarching challenge for the weak supervision in this tutorial was the ill-posedness of the problem, how to resolve ill-posedness. For weakly supervised object detection, we worked under this framework of alternating between fixing the locations and then training the classifier. And this framework is sensitive to initialization and many local minima. And this is because of the ill-posedness of the problem. And therefore, methods in this field have sought different priors and extra sources of information to resolve the ill-posedness. For example, objectness, context, boundary, scale, motion, equivariance, and so on. And now there's a shift towards end-to-end methods. For weakly supervised pixel labeling, you also require priors and hints to really solve the problem. What we mean by prior is a knowledge that's applicable to multiple images at the same time, independent of the specific instance of the class. For example, there's an overall distribution of size for certain classes, or shape, or location in the image. It could be the number of instances, or contrast, class distribution, the kind of motion, or similarity across images and similarity with external images as well. On the other hand, hints mean per instance information given by a human labeler. And that includes image labels, image captions, video labels, transfer across images, and so on. Research in weakly-supervised pixel labeling and also other weakly-supervised learning tasks are about the hunt for different priors and hints to really solve the weak supervision problem. And you can flip the problem a bit, and then you can instead solve the dual problem, which is given the constraint that your model should achieve certain thresholds, certain minimal level of performance. The model goes to humans to achieve this minimal level of performance while minimizing the human's help. So this diagram is showing how the human in the loop works. You first collect images, and then you collect annotations, and train a model on top of it, and then evaluate. And you decide whether the performance is good enough. If it's no, then you go back to the image collection stage or the image annotation stage and collect more data. And you loop this until your model is good enough. And also because of the ill-posedness, there are evaluation problems for weak supervision. Because on principle, you should not use anything else than weak supervision, but the problem is not solvable with only weak supervision. And researchers have addressed this dilemma in different ways. They have solved different ways to collect extra supervision. And this is a problem because then methods are not comparable anymore. So what we propose is to legalize the use of extra information, and then we control it under the daylight. We fix the type and amount of extra supervision, and when we do this on the weakly-supervised object localization methods and re-rank the methods in the past 4 years, then as we can see in the plot here, we don't see any improvement in the last 4 years. And this poses questions about what's the future directions for this field. We propose to think about how to build academic benchmarks and evaluation protocols for not only weakly-supervised object localization, but for other weakly-supervised learning tasks. We should acknowledge the need for extra priors and hints to really solve the problem, and include this kind of using extra information as part of the evaluation protocol and benchmarks. We could also flip the problem and then think about evaluating human-in-the-loop approach. In terms of methodologies, we need to think about how to combine different sources of weak supervision. They may have different levels and types and modalities. So it is an exciting research question how to combine those different sources. And of course, we should still look for different sources, extra sources of priors and hints. There can be still many uninvented or undiscovered sources of hints for solving weak supervision. It could also be an existing academic data set, because nowadays there are a lot of sources of extra supervision in academia. Finally, we conclude the conclusion talk by saying, First, computer vision requires a lot of data, and data is expensive. And therefore, people have been looking into weak supervision in practice because they want to minimize the labeling cost. And weak supervision still has many exciting open challenges to be addressed. And we strongly believe it is a very good time to join the field and make contributions. Thank you for coming to our tutorial.